Hello everyone, we are Group 5 challengers. Our group topic is the virtual power plant in Australia, and today's presentation I will give some information about its historical dimension. Firstly, I'm going to talk about the emerging of virtual power plants concept. Specifically, how and why does this concept become important in 21st century? Before the introduction of virtual power plant, distributed energy resources must be talked first. DERs are small and medium-sized power resources in power system. The examples include solar energy, wind energy, dispatchable loads, energy storage system, and electric vehicles. This type of energy resources, accompanied with the sixth wave of innovation for sustainable development, has become popular nowadays because of below characteristics. They are very economic, highly flexible, and renewable. So the efficient utilization of distributed energy resources is very important for sustainable development of energy. However, in spite of the advantages of distributed energy resources mentioned, there are severe challenges for them to be directly integrated into power system. The large number, unevenly distribution, and uncertainty of distributed energy resources can make the operation of power system difficult, and also may cause violation of regulations and damages. A famous example of failure is the 2016 South Australia blackout. At first, the storm led to a significant damage to the transmission lines, but the situation was worsened because the wind generation could not ride through this large disturbance with such high wind speed, and thus the high power output. So at the end, these reasons led to a terrible blackout accident. To solve the problem for distributed energy resources, people come up with the idea of virtual power plant. This concept was first introduced in 1997 and became popular at the beginning of 21st century. Virtual power plant is to provide a platform to aggregate different distributed energy resources and work as a whole in the power system. Because of the aggregation, the number of power sources connected to utility grid is decreased, and also the unevenly distributed problem can be solved too. Meanwhile, as different distributed energy resources has different characteristics. For example, the solar energy output is low in cloudy day, while the wind power output can be very large. By aggregation, these two complemented energy can make the total uncertainty high and be very low. Apparently, with the virtual power plant, the distributed energy resources can be better used. Also, this is a type of sustainable technology. Now, after talking about the concept, I'm going to focus on its development in Australia. As we all know, Australia is a country with sufficient distributed energy resources. Up to 2018, the renewable energy covered about 21% of the total energy demand. There was at least one household with the rooftop solar panels for every 5 buildings. 94 wind farms have been constructed around the country, and there are 1,930 electric vehicles charging stations. DERs are widely applied in Australia, and as a result, the construction of virtual power plants is very essential. Fortunately, the government of Australia has noticed these facts and has been giving financial support to several virtual power plant projects. In 2014, the virtual power plant Station 2 was launched to conduct a pilot-scale testing of load generation and energy storage coordination to form a reliable mechanism for matching locally generated PV electricity with household demand. In 2017, AGL Virtual Power Plant project was funded to build a large number of solar battery storage systems across 1,000 residential and business units to form a 5 million-watt solar power plant. In 2018, Simply Energy launched a project to construct a 6 million-watt of residential energy storage and a further 2 million-watt of demand response capacity. And in 2019, Australian energy market operator started a project to conduct a new technical specification test for virtual power plant to deliver frequency control ancillary services for customer demonstrations. These exciting facts symbol a promising future development of virtual power plant in Australia. At the end, I want to talk about why our group are interested in this topic about the virtual power plant. Firstly, we can see that the construction of virtual power plant has brought various benefits for Australia and its citizens. For example, there was a Tesla project in South Australia. A network of 50,000 household solar PV units were connected. The results show that virtual power plant can satisfy 20% of daily power demand. That is 250 million watts generated. Also, because of the existing network, 30% of energy bills are saved for local people, which means that they can save $8 for every million watt. These huge benefits to residents and its contribution to sustainability motivated us to further explore this topic. Another thing that is closely related to our lives are the 2018 feed-in tariff plan in Hong Kong. It allows us to build solar panels and energy storage to sell electricity to the power grid. It is in a form that seems to be very similar to many virtual power plant projects in Australia. By benchmarking Australia, we want to learn the feasibility of virtual power plant in Hong Kong in the future. You can see that these are the references for our presentation. And this is the end of our presentation. Now we are open to any questions for us. Thank you.